everybody. Today I am going to discuss about determinants and about matrix inversion. Inverse of matrix. So let's move ahead to see. Actually, here I am going to discuss about 2 by 2 and 3 by 3 identity matrix. I will show how to calculate the determinant and inverse of 2 by 2 matrix, and the added points will be how to identify whether a matrix is singular or non-singular. Then I shall move forward to show how to determine the minors and cofactors of a 3 by 3 matrix. And using these cofactors, I shall find the determinant and inverse of 3 by 3 matrix. Identity matrix. For any real number, say A, with identity property, we can write very easily A into 1. A multiplied by 1 equal to A. This is the most important properties of number 1. Existence of a number 1. And also we can write 1 into A equal to A. It means product of 1 and A is A. So to have a multiplicative identity matrix, this is very important points, because we will solve lot of problems with these properties. A multiplied by identity matrix equal to also A. So in this case, what we can say? Even I into A equal to A. The product of any matrix, any square matrix, and the appropriate identity matrix is always the original matrix. That's what this equation says, like I into A equal to A. It is the original matrix. We'll see it later with examples. And here another important things we have to keep in our mind, that A and I must be square matrix with same dimension. That is most important points too. So what is identity matrix or unit matrix? Actually, a matrix whose diagonal entries are 1, we can see it here, and all other entries are 0. Here you can see that 0 and 0. This is diagonal is 1. As well, this I2, it is identity matrix denoted by I, but this subscript, it denotes the size. As it is 2 by 2 matrix, so here it is 2. This one 3 by 3 matrix, 3 by 3 matrix, so it is 3 here. If it is 4 by 4 matrix, it will be I4. But important thing is all identity matrix or unit matrix, diagonal will be 1, all other entries will be 0. Like here we can see 0, here 0, this is all 1. Now we will multiply any matrix, say this one 2 by 2 matrix, by this identity matrix. We want to see what is the result comes. Already we read that point in previous slides. What will be the results? We can see here result will be the original matrix. So if we multiply this by this and throw multiplication procedure, like taking this row, if we multiply these two column respectively, so here element will be 3, 4, and if we multiply this by these two column, it will be 2, 1. So original matrix. If we put in other way, like A into I, here I into A, result will be same. So that was in previous slide, it was 2 by 2 matrix. But here we are considering 3 by 3 matrix A, and this is identity matrix 3 by 3, so I3. If we multiply these two, these and these, if we follow the multiplication procedure, like this row will be multiplied by this 3 column, and we will put value here in the row, then we get this as a original matrix. If it is reversed, like identity here, original matrix here, so result will be the A, it means original matrix. This is very important properties we got. Now it is multiplicative inverses. What is multiplicative inverses? Two real number whose product is the multiplicative identity are called multiplicative inverses. For example, I can say if a number 1/3 is multiplied by 3, we get 1. So this 1/3 and 3 are multiplicative inverses. So same way, here I have taken a real number A. It means non-zero. So 1 by A, 1 is number, A also is a number. That's why I can write 1 by A. But in case of matrix, I cannot write 1 by capital A, because 1 is number, capital A is the matrix. So I cannot divide that, because in matrix, that is why we know that division is not possible. But 1 by A, if A is a number, it is possible. So A into 1 by A, easily we can write 1. Again, if we reverse it, 1 by A into A equal to 1, because 1 by A equal to A inverse. So to have a multiplicative inverses for A, like n by n matrix, it must satisfy A into A inverse equal to I. N indicates n by n matrix. I mean a square matrix. Again, if we reverse it, A inverse A equal to I, so it will be also In. So this is also inverse matrix. Sorry, this is identity matrix. I mean this inverse and this multiplication, it results as identity matrix. This is important property. This is also identity matrix. So only square matrix can have multiplicative inverses. This is also important point to keep remembering. Now we shall determine, or we shall find the determinant of 2 by 2 matrix. How? This is 2 by 2 matrix A, B, C, D, 4 elements. A multiplied D, we wrote here, minus of B multiplied C. So what the results come? That will be the determinant of matrix A. For an example, A equal to this, 3 multiplied by 2, it is 6, minus 2 multiplied by 1, 2. So 2 by 2 matrix, this matrix determinant is 4. Here, one important point we have to remember always when we do matrix analysis, that is determinant A always be, it is not equal to 0. It will never be 0. It is important point. Here it is 4. So it is not equal to 0. So the matrix in this case we can call it as a non-singular. And another important point we can say, the inverse exists. It means when we have a matrix, if we see that determinant is not equal to 0, then we will know that we can find the inverse matrix of that matrix. Inverse of that matrix we can calculate, otherwise we cannot. And in this case, A multiplied by A inverse or A inverse multiplied by A equal to identity matrix, IN. N subject is the size of the matrix or order of the matrix. But not every square matrix has an inverse. There is some, it is not an inverse. So if a matrix A has no inverse, what do we call it? We call it as a singular. We have to keep it in our minds. Inverse of 2 by 2 matrix. Here we can see the same matrix what we have seen in the previous slide, A equal to A, B, C, D. But what I did, I wrote here directly what is the result of A inverse. Inverse of this matrix I already wrote here. But one thing I have to tell you, this one, to bring it as this shape, this value or this, the type what I have written here, like A, D, A, minus B, minus C, we can do it. There is different procedure is there, but it is a long process. So I am not going to do that. What I will do, I will do a special techniques to write this. What is that? Whenever I get any 2 by 2 matrix, right away I will swap two numbers A and D. This A and D I will swap. What is that? D I will bring here, A I will bring here. As well, this direction, these two elements, I will change the sign of B and C. Like here, AD, I put here AD. Just swap. Then this is B, I put here minus B. This is C, here I put minus C. And 1 by this determinant of matrix A. Right away, I'll get the inverse of A. For an example, here this is a matrix. What I did, same procedure I followed. Swap two numbers. 3 bring here and 2 bring there. 1 put negative, 2 put negative. Now 1 divided by 4. In previous slide we saw this matrix determinant is 4. So I put here 4. Now 1 by 4 multiplied by this, we get the matrix like this. So this is the result of inverse matrix A. Now question is this correct? How do I know this result is correct? So what I will do, I will multiply this inverse results with the original matrix and to see result is identity matrix or not. So according to multiplication procedure, if I do this multiplication, result will be this. You can check this. So what you can say, A into A inverse or A inverse into A equal to identity matrix. It is proved. So our inverse is correct. Now we will concentrate to see how to find the minors and cofactors of a 3 by 3 matrix. This A matrix, it is 3 by 3 matrix because 3 column 3 rows. Now we can write like this. This A11 multiplied by this 4. I mean this is called minors. When we take this one, then we have to cancel this line. We have to cancel this line. The remaining is this 4. So we have to multiply this by this 4. So I did this. Again I have to put minus. If you look at this one, you see this position is minus because I am here. A12. So here I will cancel this line column. I will cancel this row. So remaining is this and this. So it came here. Only sign instead plus I put minus because minus here. But I will show you later how to bring it another way because now I am checking this one, but later we'll see this formula also we'll see. And then plus A13. So if I cancel this row and this column, so I have remaining this 4. So as a minor I have to bring this here. This is all are called minor. Now this minor, here I am showing if this minor is multiplied by this minus 1 to the power ij. What is ij? Position. For an example, here plus. So A11 is position here. So if I put 1 plus 1, so it will be 2. So even number. So it will be positive. That is why it is positive here. Now for this A12, I value 1, J value 2. If I put I1, J2, it will be 3. It is an odd number. So it will be negative. That's why it is negative here. Again, this one A13, it is this position. So 1 plus 3. So if I put 1 plus 3, it will be 4. So even minus 1 to the power 4. So this one will be plus. And this Mij, which is called minor, if it is multiplied by this sign, then if we use the sign with this, then this totally we call it as cofactor of Aij according to the positions. Now we'll find minors and cofactors. Previous slide it was generalized formula. Now we will find really from the example. So we know this is A11, this position. Now same formula used, like minus 1 for this position, 1 plus 1, and this already I put here a square mark. This is the minor, I put it here. So with calculations, I got 9 minus 7 equal to 2. Where I will put this value? I have to put all this value as another matrix that is called adjugate matrix. See here 2, I put 2 here. Again A12, these positions, I found this 1 plus 2, so it is negative, and these are the minors 4 and 2, 7 and 3, so my result is 2, so I put here 2. For third, same procedure, I got minus 2, so I put here minus 2. Then 2, 1, I got minus 11, so I put minus 11 here, because 2, 1, A21, this is this position, so I put here minus 11. Same way, I have to calculate the remaining A22, A23, A31, A32, A33. All the values I put here. So total this matrix is called adjugate matrix. Now what we will calculate? This one we will see what is the determinant value. So for calculating the determinant of 3 by 3 matrix, we can choose any row or any column. Let us choose here the second row. So cofactors corresponding to the 3 elements 4, 3, 7 in the second row were found to be minus 11, 4, 6. In the previous slide, adjugate matrix, we have seen this value in the second row. So we have to multiply this by this. So we get the determinant of A. We can we'll check considering other one. What is that? Second column. Second column, this one. Same way, these three elements 4, 3, 1, and previous adjugate matrix we had this value in the same column. So we are multiplying this and we got this 10. So as I told, if I take column or row, whatever I take, determinant will be always same. Now I wrote here already in the previous slide we got determinant 10. So I wrote it here. Adjugate matrix, already previous slide we saw, we got this one. Now if I write this matrix as a transpose condition, transpose of adjugate matrix will be adjoint matrix. So like this is the row, I put here column, this row as a column, this row as this column. So A inverse for 3 by 3 matrix, how we will find? Formula is 1 by this determinant value of the matrix multiplied by A adjoint. So what is that? This matrix. So it will be 1 by 10, as we know determinant 10, and A adjoint, it is this matrix. Now after multiplying, I got inverse of 3 by 3 matrix as like this. So this is our result, inverse matrix. But we want to be sure with that our result is correct. So what we will do? We will multiply this with the original matrix. So this is our inverse matrix, this is the original matrix. Multiplying these two, we find these results. What is that? It is identity matrix I3. If we reverse it, like if we make this in reverse, like A inverse A, this is A inverse, we find the same result. It is also same identity matrix of order 3, 3 by 3 matrix, square matrix. So it is proof that our this result is correct. That's all for today. Thanks for watching.